Welcome friends, we are again here in the Geometrifying Trigonometry demonstration, and several people are asking that its plus minus into divide looks like something near around vector algebra, and some people are talking in that direction, but strictly speaking, Geometrifying trigonometry is entirely a different subject than vector algebra, and it is not purely trigonometry, not purely Euclidean geometry, but obviously the fundamental target is to read the expression of trigonometry equations like thing identities, inequalities, or trigonometry expression, any kind of trigonometry expression, the power series, or even the algebraic expression, the Fourier series, whatever, where the trigonometric ratios are used or any kind of ratios are used, we can draw the pictures automatically through the parser technology or through several different algebraic structures, such that computer can automatically generate the pictures of given trigonometry expressions or algebraic expressions or Fourier series, not as the graphs. Please don't confuse with the graphs that we see on the Excel graph chart or the line diagrams or those things. We are not talking about those graphs. We are talking about the geometry which we draw with the triangles, polygons, and circles. In that way, suppose here you can see the diagrams and the kind of diagrams that you can see here. These are not graphs, these are pictures, these are Euclidean geometry things. The interesting thing here is geometrifying trigonometry claims that cos to the power n theta can have this picture also, and cos to the power n theta can have this picture also. How? Because cos theta has 4 different symmetries, sin theta has 4 different symmetry, tan theta has 4 different symmetry. Every of these ratios have 4 different kinds of symmetries every time, because for vector algebra there is a one arrow, one direction. For geometrifying trigonometry we treat everything as a line segment, and line segment can have directions both sides, sometimes on the right side, sometimes on the left side. So geometrifying trigonometry deals the line segments as the fundamental object of study, and one line segment is acted with the plus minus into divide, and then it generates another line segment, and triangle has 3 line segments involved in that. 2 line segments are automatically found now, one was given, another is generated, so in connecting the endpoints give the third line and a triangle forms. This is the fundamental logic of triangle formation through the actions of plus minus into divide. Here the demonstration was shown to identify that cos to the power n theta can have multiple pictures, and 4 to the power n number of possible pictures are there. We have shown here only 2 samples, good interesting samples, such that one kind of transformation can give us the total length in one way, and another kind of transformation of the same equation can give a different picture, and we can get different integral values, but numerically both can have the same value. So sometimes if we try to find the length of the green lines here, then it becomes tough to calculate in this way, but if we transform it in another way, we can easily calculate the total length of the green lines. So it becomes easier to do the transformations, and wavelet transformations are also possible through this geometrifying trigonometry. We will show all these things later on in the other videos. We have already the simulator available, freely available in Autodesk forum. From there you can download that and can get that. Now we will show you how the vector algebra is different from geometrifying trigonometry. We will try to show the conditions of the plus minus into divide, and in multiplication is already shown in the simulator in the previous video, and here we will show something about the plus only. In the other videos we will show about the minus conditions, and such that we can demonstrate that in better way. Suppose for this case we want to delete this picture here. Now suppose we want to show you the line segment. This is a line segment. One line segment is given, another line segment is here. What can we do here? The two types of plus are possible. One is the cumulative plus. What we do in the cumulative plus, the start point of the second line, since it is non-commutative, the first line is kept in the right at that position. The second line is lifted and shifted in such a way that the first point of the second line is placed on the second point, last point of the first line. This is one type of addition, which is the cumulative addition. If we have another line, then we can do the cumulative addition. How? Just lift it and shift it in this way and put it at the end of this line. This will give us the cumulative addition, and this is cumulative addition case. If we want to do the non-cumulative addition, how can we do that? Suppose this is the first line, this is the second line, and this is the third line. We can name them. Suppose its name is, we can say fit its name here. Suppose this is the first line. Caps, it takes in caps only, and underscore is not taken here. It is the first line. Its caption is first line segment. It is the second line segment. And it is the third line segment. These are the things here. Suppose we are taking it in this way. Now for vector we do the parallelogram law or the triangle law. Here we will not do that because that is not allowed in geometrifying trigonometry. One thing we could do was the cumulative thing that we have shown already. Now we will do the collinearization. Collinearization is another interesting subject. That is, we will take this line here. First line is the governing direction of the collinearization. We can add on the end side also, or on the first side also, but first convention is that for the different kind of additions we have the precise, rigorous meaningfulness that on which side we are going to add. For that the different symbols of plus are used. For cumulative addition also there are the different kind of plus are used. Here we will draw a circle. First we will, before drawing the circle, we will draw a infinite line here from the first line, and infinite line is with color gray, and style is taken as, suppose line style is this, with thickness is very less. This is to demonstrate that our system is going to take the first line as the reference direction on which we will do the collinearization, not the cumulative addition. If we had to do the cumulative addition, we could do it lifting and shifting only. If we had to do the cumulative addition, we could do the lifting and shifting only. And if the line segments are different, then we could do it in this way. Now if it is kept in this way, if we now do the collinearization, how can we do that? We will draw a circle with center and radius. The center and radius means it takes the center and also the radius from other point, and center and compass data. What is the radius? Now for this compass, select the center point and it asks for the radius. This is the length of this is the radius. Now we can put it here. If we change the length of this point, if we change this, if we change this, then the radius will change, so we will not change it. And it is sure case that the center is fixed as the end point and the length is taken from this second line, and we are keeping the second line here. We can move the line anywhere until the length is changing. This circle is not going to change. This circle is also a reference construction circle, and we are putting its color this and its style to this, and thickness is reduced so that we can understand it easily. Now we will take the intersection point here, intersection of this constructed circle and this constructed reference direction line, and then we will get the collinearized segment here, which is the replica of the second line. This is the replica of second line, which is the collinearized second line, which is collinearized second. Okay, this is the collinearized second line. In the same way, we can draw the circle with the center and compass, where the center is the end point here and the compass radius is this one. So we can put it here, and now we are taking this as the reference, and if it is the reference, then its color is taken in this way. It's not mandatory, but I am taking it as a convention to put its color in this way. We are taking it here, its reference is like this. That helps us, and again we will take the intersection here with the reference line, direction line and center. This gives us the replica condition, and we will draw the replica here, which is the collinearized collinearized third line, which is collinearized third line. If we change the length of the third line anyhow, then you can see it is changing, but its point is changing, but you can see that this point is not moving, and this point is the controller governor of whole assembly, because this is the first line is deciding the direction and second line has no rights to change it. If the length of the second line changes, then only it changes the second point, otherwise it is not changing. So if we take it cumulative, then the addition will look like this. If we take it cumulative, suppose cumulative addition is done, then for the cumulative addition the direction of the movement of the integral curve will go in this direction, that is the integral curve, and no parallelogram law nor any triangle law are used. Here the cumulative addition is done in this way, and the collinearized addition is done in this way. This is the behavior. For the negative cases, we will take the reverse side dots and we will move in the reverse direction. For the negative cases, for minus, to do the minus, the cumulative subtraction or the cumulative addition, we just do the end-to-end adding or end-to-end subtraction. For the case of collinearization, we take the first line as the reference direction and we add the lines one after another. The first point of the second line comes to the second point of the first line. In the same way, the first point of the third line comes to the second point of the second line, and collinearized with the line lengths are copied, but the directions are kept as per the governing direction of the first line. In this way, we do the collinearized addition in geometrifying trigonometry. That is the important difference between geometrifying trigonometry and with vector algebra. So the plus is shown here. We can show the minus in another video. The multiplication, division, they are the separate cases we will study. Then we will study about the different symmetries and with how to construct the whole algebra here, and then we will go for each problems and expressing the problems of textbook through the geometrifying trigonometry. We will represent every equation and expressions of trigonometry book to the Euclidean geometry, and we will try to find new theorems out of that. And we have the names, beautiful names of the points, beautiful name